Thanks everyone for being here. So we'll start off with I understand the end goal which you have in mind is to talk about OSM, but we'll start with what are maps and what Google Maps does, because that will provide us with a good background of what and how powerful OSM actually is. And today we are sort of going to go all over the place to reach our end goal. So we'll firstly start off with my first love, which is maps, which is I just aim to open your mind to looking at things from a different point of view. Then we'll talk about Google Maps, which all of us know. But to really understand it, we need to understand what exactly is it that Google Maps provides us and why is it so sticky? Why do all of us use Google Maps? And then we'll come to what OSM is. How do people create maps or create map data in OSM, and how is that data used? And finally, we'll talk about how that data is checked, what is the process, or how does the data keep on updating, and how you can extract data out from the OSM ecosystem. So feel free to ask me questions whenever they come to your mind. I generally like it to be a little bit interactive. And while I talk a lot about OSM, none of my two talks are ever the same. So it's all very flexible depending on what the audience is. I'll start off with who I am. So as such, I always say I am the Tengshe. I love maps. But my background as such was I initially thought that maths and physics is the best thing in the world. So I did my graduation in physics in Mumbai itself. I'm born and brought up in Mumbai. And then I realized that while it's all interesting, it's not as interesting as maps are. So then I sort of started figuring out what is it that I can do with maps. And then I realized there's a whole field of uh, dealing with geospatial data called geoinformatics, which is what I've been working on for the last 17, 18 odd years, where I've been working with enterprise customers, government customers on how you can apply geospatial way of looking at things. And he mentioned Jodhpur. So I was in Jodhpur because I was working in ISRO for 2.5 years, working in their regional remote sensing center, working with uh, satellite based data and how you can utilize that for water resources. So this is sort of my professional background. But I got into this field because I love maps and I love figuring out how more people can use maps. And I came to know about this project called OSM or OpenStreetMap in around 2009. And I've been a contributor since then. So we'll go through the entire field, but I'll begin with my first love, which is maps. And I love maps because they open our eyes to looking at the world in a different way. We are all used to looking at the earth or a map of the earth where you have the northern continents at the top and the southern continents at the bottom, but we really don't know how the world looks. So I often show this map. Now, many people will question whether it's a map, but that's a different discussion. I'll just like to ask, what do you think when you see this? What do you feel when you see this? Right? All of our assumptions of what the earth is are completely shaken by this. Why? Because we look at it from, say, a point of view of being on the earth, going from one place to the other. But imagine you were Captain Nemo on the Nautilus, going 20,000 leagues under the sea. You would be interested in the sea. Forget that. You were a fish and you wanted to know where I can swim to. All of our oceans are connected to each other, unlike the land. So this was actually made by somebody working in one of the oceanographic institutes in the US, where they wanted to show how things are connected to each other via oceans. So this is a good way of this is a good example of how maps open up our understanding of the world and make us look at things in a different way. Another sort of map which people often talk about when they mean a map is something like this, where distances are exact in all directions, or you can read heights, you can read contours. So this is what is called a topographic map or a topo sheet made by the government of Nepal. And there at the top, there in a zoomed in way, you can see Mount Everest and you can actually read the height, 8848 meters. So this is usually what people would think traditionally would be a map where things are exact and things you can be definite. But very often, as we know in our world, things are not very definite. Things just emerge. And this is an example which I often use now. It's almost 15 years old. Any guesses to what this is? Exactly. So this was made by an intern in Facebook at that time in 2010, what he did was just plotted each and every user on Facebook and their relationship to each other. Suddenly you start seeing all these patterns emerge. Like, for example, quickly jumps out to you that they don't have users in China. Or you can see how Africa, really, there aren't many users there. Or if you, emptiness of Russia, or even Australia for that matter. And you can start seeing things emerge directly out. So maybe this is not a map, but it shows you things coming out from a geographic point of view. Now I can look at a table of users and try to make patterns out of it, but something visually will come out only when you look at it from a geospatial or mapping point of view. Now, of course, Facebook is Meta, and most of us are not on Facebook anymore. If you look at, say, Instagram, something similar will come about. But there, maybe they will be grouped by interest more than location. Because at that time, Facebook, usually you knew the people who were your Facebook friends. Nowadays, I don't even know the people I follow, except for the content that they post. This is a map which I had again created around 10 years back. This is Bangalore. Anybody has any idea what this is? Okay, possibly road networks. Anything else? So no. So this is when I had gone from Bombay to Bangalore. People used to say the public transport in Bangalore is better. So we plotted all the bus routes. So on the same road, if there are more number of bus routes, the brighter it is. So we have just mapped the bus stops which you don't see and the bus routes following all those bus stops. And suddenly you can make out which part of the city is well served by public transport, which is not. So the brighter white is more number of bus routes on that particular location. The red is just the ward boundaries of Bangalore. Another thing which comes out when we look at data from a spatial point of view is something like this. Now, these are two different parameters from the census in the UK for Manchester. Any idea what they are? So, on the left, you have the percentage of residents with level 4, that is, say, our secondary education. And on the right, you have the percentage of residents employed in manufacturing. There is definitely some relationship between these things. You could maybe make it out by looking at that tabular data. But when you place all of this on a map, that aggregate information just jumps out at you when you look at it from a spatial point of view or a geospatial lens. And that's why maps are so interesting and important. They also tell you this historic effects of certain things which we don't even know about. So this is an example which was posted on Reddit some time back. And I love this map because the first map is showing you the sort of the sea coast of the continental United States around 150 to 100 million years ago. So that is during the Cretaceous period, all the sediments of, say, the prawns and all of those kind of sea animals, whatever exists at that time, where they are deposited. Then the next map is the area where you have fertile black soil in the United States in the state of Alabama. The third one is the average farm sizes in Alabama. So you can already see some pattern emerging. Then the fourth one is the percentage slave population in 1860. Again, you can make some pattern out. Then you have the black population in 2010. So you can very clearly make out that not much migration has happened. And again, you have the election results in 2020. So clearly there is some relationship there. And of course, why these states or why these counties vote in a certain way, of course, there are sociological reasons for it. But there is a big geographic reason as well. And all of these things are only visible when you look at it from maps. The maps are also useful to see how the world is changing. So this is a map. Now, the Chinese cartographers are great at changing the way in which we look at things. Very often in the Western world, people don't even look at it that way. So this is a map showing the Chinese routes for trade, which have opened up now after your climate change has happened and the northern passages are open throughout the year. When we look at a normal map, say a Google map, we see that we don't even see the North Pole or we don't even see the South Pole. So we would think, oh, what does it matter And why is China building all these things? But suddenly you can see that all of their trade goes through the northern route. And suddenly now the US for them, Europe for them is much closer than what it used to be earlier. This is, say, the many people would say the shapes look odd, right? My answer to that would be those shapes are just what we have assumed them to be. Who told you the shape is like that? The shapes are decided by, say, at the end of the day, the projection which is used to create the map. Projection is nothing but a fancy term for the formula, mathematical formulae that we use to go from a sort of spherical earth to a flat map. But each map changes something. Some will preserve the shape, some will preserve the direction, some will preserve distances, but no map can preserve everything. So anybody who's building a map has to think about what they want to preserve and what story they want to tell. And these kind of maps are great at sort of looking at the world in a different viewpoint. Another Chinese map which I love is this particular map. Again, they are putting China at the center, but it shows you how they want to be connected to the world overall. If you look at this map, you will see why so few of their projects are in South America, and most of their new projects are focused in Asia and Africa, because that's very close to China, right? These kind of insights you will not get if you just look at static maps. And this is sort of the new thing in today's world. Maps are no longer these static paper maps which we used to preserve and keep in our sort of cupboards. Most of us use maps in two ways. One is on Zomato and Swiggy, when like figuring out where my food is, where that guy is stuck and will he come to my place or not. And second is usually using something like Google Maps, right? So most people, when I talk about maps, when I began working in this field, it was a big pain explaining what I do. But now almost everybody uses maps in some or the other way. Most of you would only use, say, the Google Maps, which you see over here. But there are other apps as well. I don't use Apple, otherwise Apple Maps would also be there. So you have one which is based on OSM called Organic Maps. Then we have the sort of Indian map called Mapples, made by Mapma India. You have Google's mapping application on your phone. And then there's something called Here. So these are just some of the examples of mapping mobile apps that we have. Just take a moment to look at it and figure out that the same information, this is the same location of my office in Pune. The same information or the same area can be represented in different ways. And different organizations or different companies are choosing to highlight different things. Many of us are so stuck in the way of Google Maps, so that feels very natural to us. We think of, say, green being a road where there's not enough traffic, red being high congestion. Sometimes if you're really unlucky, you see that scarlet red, which is really, I'm not going home tonight kind of thing. But there are other ways of showing the same data set as well. And at the core of all of this is that it's not just a static map. There are multiple features that we are getting. And what do I mean by that? If we understand that, then we'll understand why that data is very important. So anybody who uses something like Google Maps uses actually multiple different features. I come from a technology point of view where we build a product and we talk about its features. So I'm using that language. Maybe somebody from a different background will use different language for the same concepts. But let's break any mapping app into the features which a user would be using. So first of all is the interactive map interface. It's no longer static. We all zoom in and zoom out using this. In fact, when I met my 3-year-old nephew for the first time, I gave him a magazine. On the magazine paper page, he was doing this because he's used to the iPad. So it's something very different. Somebody was using my Kindle, the old Kindle, and again, it has no zoom. So he's like, how do you read this? But this is something that we have become so used to. A common example which I tell people on how you can figure out who's a millennial and who's not. You ask them, how do you show a phone using your hand? The older people will do this. The younger generation will do this. Right? So maps is something which has become very natural to all of us. We expect to zoom and pan around it. But one thing which most people cannot do is that without that blue dot, they can't orient themselves. Without that directional blue V, you can't figure out which direction you're looking at. right? So that is also an important feature of the mapping app. Then many of us use it for routing and navigation. So that feature is possible because you have road data, you have the road network, you have the connections between the different roads. Then you have the additional turn by turn direction. So you will need to know the names of the roads. In India, Google tells you the directions based on points of interest, like turn right after the temple, right? Or go straight till the petrol pump and then take a left. So I think India is among the few countries where you have navigation based on points of interest rather than just roads. Many people would have forgotten that earlier you had to use these paper maps and figure out which direction you're going, where you are on the map, and so on. So this is something which has completely changed while driving. Additionally, Additionally, you will have other modes of transport. Like most of us use it for driving, but for example, today I use it for walking from the metro station to here. So you have walking mode. In cases, you will have things like, okay, for three-wheelers or two-wheelers, or even for some specialized functions like for trucks, there are certain roads which you can't drive on. So trucks usually have a different navigation system which highlight the roads and the times at which the uh, truck can drive on that road or not. Then most of us start by actually not entering a lat long of a place, but by searching a location. Like I put the location of this place by searching for the name, right? So there has to be a way of searching or going from a name of a place to a location internally. And that is something which is very challenging because unlike in many other Western countries, addresses in India are very challenging. So you will have several different names. It's not a house number, street number, and neighborhood. It will be anything. And also, we don't have a specific way of calling things out. Like, for example, where does Chakala end and where does Andheri start? Right? So these are some challenges which have to be solved because you need to go from that specific name to a lat long internally for uh, going to the right place. Additionally, if you are interested in, say, something like trekking or so those kind of, or like me, I used to bike in places like Ladakh and those kind of places where you don't have network. So you need to have the ability to have offline maps. Now, this is something which has become very easy with Google Maps, but earlier it was very difficult because Google Maps didn't have that function. Now, that is something which people expect and we need to build. And then you all obviously have traffic information, which is the biggest reason why most of us use Google Maps, because it gives us accurate ETAs of how long something will take. And because so many of us are using the app, we are all sending our data to Google. And that's why Google is more efficient and accurate when doing these calculations. So it becomes challenging for anybody else to build an app to give the accurate accurate ETAs because they don't have this congestion information. Very often all of us are used to that top down view, but for example, when I came here, I wanted to know which building I have to get into. So you need to have some kind of street view and 3D view. Without that, you can't really figure out where you are. Like for example, imagine you are somewhere in Tokyo with a place like this. Just having a location on a map will not tell you which side street supposed to go in or which building you're supposed to go in. So without these kind of additional features, it's very difficult to reach your intended location. And finally, public transit information is very useful when using these kind of apps. Now, in some places, Google Maps is great. Others are better. Like from what I hear, people use M indicator to figure out the running status of the trains. But if you're in Singapore, you will get even the running location of your bus on Google Maps, which will tell you in 3 minutes a new bus is going to come. Right. So this kind of information is also something which people tend to depend on when using these kind of mapping applications. So this kind of gives you a background on what is expected when somebody talks about maps. But there is a new kind of way of looking at this mapping, what say the landscape, where the application is something which anybody can build. But together we have to build a common data set. And that is where OpenStreetMap sort of comes into play. As a background, you can say that OpenStreetMap is kind of the Wikipedia of maps, where anybody can come and enter information. Other people can come and verify and validate that information. You keep on building on that information and you have a map at the end of the day. And the idea as such, when it began, was not so big. It was just a student in the UK. He said that I want to have maps of my university. And at that time, even Google Maps had not actually started. So they had to get data from their survey of India called Ordnance Survey. And that data was very difficult and very expensive. So he said, why can't I just walk around with a GPS and draw the map myself? And that was a simple idea which began in 2005 and has slowly grown today with thousands of users. In India, you have, for example, something like 250 to 300 users daily editing and creating new data every day. Overall, the concept of OSM is that there's no centralized agency creating these maps. It's all local knowledge. The community works together to create these maps and create the data set. The data is completely free to be edited by anybody. So there's nobody who can say that this is the data. It's all by consensus. At the end of the day, anybody can add to the map. You can add as much information as you know. So for example, I may just know that there's a road here. I may not know what name to give it or how to add quality parameters to it. So I can just add that road. Somebody else who has a local knowledge, who has a technical knowledge, can add that additional information to it. And slowly over time, the quality of the data improves. At the end of the day, the biggest sort of reason why OSM is so popular and so useful is that it's the only mapping platform which gives that data out for anybody to use. One of the biggest sort of problem with with Google is that while it's great to use as a consumer, for using it, the APIs or for any other purpose, you don't have access to the raw data. You only have access to the data which they give you. But on the other side, OSM is something which gives away its data freely for anybody to use. And that's sort of the strength. So we'll quickly talk about an example. So this is in Tanzania, in Dar es Salaam. And this is back in, I think, 2016, 17, when first of all, Google was not interested in mapping that area. B, they didn't have enough government, capacity to build those maps. And there was this community in what we would call a slum who wanted to figure out that every year there's a flooding. Which are the houses which will be affected? So they got together, built created this data on OSM. They mapped each and every small street, they mapped each and every house, and then they could put it on the map and actually do some analysis to figure out which are the houses which are affected by floods every time. So those are the orange ones which you can see. This is something which won't be possible with any other mapping platform like Google or Apple or anything else. Yeah. You can I'll come to that. You can also draw the boundary of the house, the polygon. You can draw anything. So as long as you can locate it accurately enough for your purpose.
Yes. GPS resolution is like 10 meters.
No, if you have a good GPS, it's 3 meters technically. And there's a system where if I have one GPS which is stationary and another which is moving, it's called kinematic GPS, which can be up to centimeter level. At the end of the day, it depends on my purpose of what I want to use it for. Like if I look at satellite imagery and draw on top of it, then I can draw maybe up to say 1 meter level accuracy, which is good enough for doing this kind of analysis. Of course, if you want to have exactly whether it's 1 meter flooding or 2 meter flooding, then obviously you need more accurate information. But there are ways of getting that if you so need.
Okay. So just to ask, like, if you're asking if anyone can contribute, like Wikipedia, you need to provide sources. Is there some kind of evidence that you need to provide? Because, like, say, photos or whatever, say you want to change the name of the road, all this stuff.
So generally, no, you don't need to provide a source, but I'll come to how that QCs are done. Usually what will happen is over time, there are enough people looking at the data to improve it. So if you put something wrong, somewhere something will break down the line and somebody will come and look at why this happened. So there are ways to check. Of course, it's not 100% accurate, but there are ways to correct it if it's wrong, which is not possible in proprietary data sets like Google. Yeah.
So are there technologies which allow us to map things at a height? So for instance, this building is some urban complex, but XKDR office is on second floor, take a left.
Right.
Are maps built like like that, where I can sort of locate within a large structure things that are.
It's possible. So this is called indoor mapping, where you can first it is three-dimensional mapping. So there are buildings in OSM which are nicely done. Like for example, if you look at the Empire State Building, you can get like the proper 3D shape of it. Additionally, you can put say the level at which the office is. There are those kind of parameters which you can add to an address saying that this is in the second floor. So it depends again on your purpose which you for you which you're using it at. Like for example, in a mall, having that three-dimensional mapping would be very helpful, but you don't necessarily need it for everything. Because this is a community-driven project, if your area of interest, like you are interested in mapping a mall and all the different shops, there are ways to do it. Nobody will stop you. But there's no compulsion for everybody to map everything in the same way, which is sort of according to our own use cases and our capability, we can map up to certain levels, right? So this allows us the flexibility to do all of this. I'll come to that a little bit later, but yes, it's definitely possible.
So potentially, like Phoenix Matrix, we can take OpenStreetMaps and say that we can map the entire
Yes. And organizations have done that.
How about, but then how about like areas which are restricted? Filming or whatever like that.
So nobody's stopping you. So funny enough, like for example, people have mapped things on OSM which maybe the local government would not like. Like one of the main reasons why OSM does not have an India official foundation or chapter is because nobody wants to be responsible for the wrong boundaries, right? But the philosophy of OSM is to show the reality as it exists rather than what laws tell you. So there are, like, for example, you can query and find out military installations, nuclear power plants, those kind of things, not only in India, but across the world on OSM. And at the end of the day, people verify whether I can see it. There's some way of verifying. Like very often, just by looking at Google Maps, you can make things out. People also map things based on newspaper reports, saying that at this location, there is a submarine base. Of course, from satellite view, you will not see it, like the one which is built near Vizag in India. But based on newspaper reports, etc., people can make out, okay, this is the entrance to a submarine base. And this whole field of getting data out from open sources is called OSINT, which is very popular. So it's not, at the end of the day, because nobody's controlling it, nobody can control it also, right? So it's very easy to get started with OSM. All you need is an internet connection and access to the internet to create an account. Before we come to that, I'll just quickly get into this data model. I don't know how many of you are technical here, but okay. So for you, so one of the sort of the important or the strength.
We make lawyers write LaTeX.
Yeah. So the strength of OSM is that the data model is very simple. Everything is represented by nodes, ways, and relationships. So node is nothing but a point in space. It can be 2D, a lat long, or it can be 3D. Then your lines and polygons are represented by something called ways. That is a collection of points. And then in certain cases, you will have multiple things grouped together by something called a relation. So let me give you an example of why this is so weird in the field which I come from. Normally, people talk about objects that this is a road, this is a railway line, or this is a building. And they are all disconnected from each other. They just exist in space at the same location. But in OSM, the road and the footpath will be connected to each other. Or the place where the road and the railway line cross to each other will be marked as a railway crossing. So you have this connectedness at the center of it. And the flexibility is such that at the end of the day, it is simple XML, like this very building is represented by this XML structure, which is, I just have a way ID. Right now it's version 1 made in 2015. And then it just has these 5 points where the first point and the last point is the same. And it's just marked as building yes right now. If this is all that it expects, like you said, I want to add the 3-dimensional nature of it. I want to put the height. I want to put the name. I can add all of these as tags to this object.
Count the nodes. I think 5.
Yes. And because to complete and close the square or the polygon, the first and the last one have the same ID.
Let's just walk us in the
So, okay.
use the mouse.
Okay. So I'm not sure. Maybe suppose this is the first one. This is the second one. Third, fourth, back to one.
So the first is
Yeah. So 5 entries to close the loop.
And what are the triangles in the
Sorry, triangle was. Oh, so this shows us the direction of how it was digitized. In this case, for a building, it does not matter, but for a road, it matters when this is marked as a one way. Because on this road, you're supposed to go in one direction. Don't tell the bikers. But
this is just defined by the manner in which the polygons.
so, yeah,
So if you reverse this entire thing, the road, I mean the order of these points, it will be
yeah. So it may matter in certain cases. Like for a building, it does not matter. For a road, it may matter if I marked it as one way. But for example, this road, which has been marked, it's not one way. So it doesn't matter in which way it was digitized or which way the points are there. So yeah, so you can see that this has a way ID 353179. It gives you the information of in what chain set it was done, what time it was done, by which user it was done. No, there's no node. These are the nodes which are there. Yeah. Collection of nodes. Yeah. Right. And additionally, you will see that there's a tag of building is equal to yes. I can add additional tags of the key and value. Yes, I can add additional name, number of floors, owner, address, a lot of other parameters I can add, but I don't need to add. So everybody can map according to their capability. And so there, you can create, 1 minute, you can create new keys, but there's a sort of a standard, what is normally accepted by people. So generally building would be BUILDNG, name would be small NAME, it won't be capital NM or anything like that. Time. Yes. 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 So, yeah.
fix these different types of tags? For example, symbolic, which is circular or some
Yeah.
shape.
Not necessary. You can do according to your ability. You can put maybe a square. Somebody else will come and correct it. Somebody can say, okay, it's not exactly a square. This side comes inside, so it needs 3 vertices instead of something like that. So it's the
not too large.
yes,
In Wikipedia, we have no wrong information.
right. You do that happens with any what do you say, crowdsourced project, but there are processes set up to highlight these things. And what usually ends up happening is there are people, like for example, I map in a particular part of Pune, so I usually will end up looking, we'll come to that later, I end up looking at what other people are mapping in my area and tend to correct it. So this is, as in people will often say, and this is a question which we talk to our enterprise customers, does this scale? My answer to them is that humans are the only things which scale. And only when you have committed individuals doing it for their own reasons does it scale. So it, yeah,
We had a question.
is the ID of the polygon object.
So the word way that is an object.
Yes,
A node is a point.
point.
XY coordinate is a point.
Yeah. And a relationship would be, say, for example, you talk about the Western railway line, right? So then there are these individual ways. So together we'll sort of mark them as a relation that all of them together should be referred to as the Western line. You can mix up anything. You can have a relation of relations. So exactly, it's a grouping at the end of the day.
So for more critical areas, you might see malicious attacks.
I'll give you a simple example. I don't know how many of you played Pokemon Go. So when you play Pokemon Go, they spawn at, say, green areas or water bodies. So one of the ways in people try to hack it is because the data comes from OSM, they went and marked ponds and waterways near their house. So they will get more Pokemon. So it's definitely possible. Again, at the end of the day, you have to figure out a way to get, can you trust this 100%? No. But you can't trust anything 100%.
No, the
Yeah.
idea behind asking this was you have different fidelity for different types of those
Correct.
places. I might be able to trust it for my route from my home to the office.
Yes, exactly.
I have a sliding scale of trust.
Exactly. Like with any other.
It's not like other maps are better.
Yeah.
Google Maps is full of mistakes. I am a inveterate contributor. I keep on supplying good data to Google Maps. So
No.
nobody is perfect.
No. I guess you still have some safety teams who would
Not necessary. In fact, if you notice Google Maps, the quality has gone down the last 3 years. Has anybody noticed this? Last, compared to what was 10 years ago, Google Maps quality has gone down. And why? Because I was talking to the team, they are now using more AI ML processes to validate the inputs. So a lot of wrong inputs are now being accepted. That's why the quality of Google Maps for routing especially has gone down. And you read about all of these like shops which
For
are,
a long time, suburban building
yeah,
across the road
Yeah.
on Google Maps.
Yeah.
And I'm like a, trusted local guide,
Yes.
blah, blah. I had to submit this 6 times because the first 5 times he rejected it. So, no, your fact is wrong. Your fact is wrong. I just kept on hammering, giving it to him again and again. And then finally he accepted that, oh, Samarpan is here.
yes.
When people fall off cliffs and fly over,
Yeah.
then no teams to take risk. Because when you say accept, when you sign up for Google Maps,
You're accepting
Yeah,
online.
of course.
Yeah.
That's fair
Just
also.
Okay.
that we know where he's coming from. He used to work for YouTube. So he's thinking that, Google puts hundreds of people to fight his battles. But I want to say to you, this is terabytes of data.
No,
Hundreds of people cannot fight data quality on the scale of these maps.
I'm asking, my point is, I get it. My point in asking was, are there safety mechanisms in place? And
So safety mechanism is other people looking at the data.
And is there a wiki?
No. Everybody is at the same level. Plus, but there are there's a data working group. So if there are enough complaints raised about you, I can raise it to the data working group that please look at his edits.
immunity mechanism.
Yes. So, generally, it's at least here it's an India data group, and then in the US there are statewise and things like that. So it's just self-organized. Yeah.
But I guess my question is, does that information expensive value by 3 as opposed to
Right. No. The only, again, there are cases where some data has not been edited for a long time. Like this building has not been edited in 10 years. Does that mean I trust it more or trust it less? Right? There's a case to be made that because nobody has edited in 10 years, maybe it's correct. But on the other side, the building may not exist today. Right? So, yeah. So there's no right way to do this. Yeah.
no chance?
Yeah.
Percent in general.
Yeah.
Is there a rule for
So generally, this is community driven, and there are organizations. So there are other large organizations who build their maps on top of OSM. So they have their own processes for validating and verifying data before ingesting it. So there is no common consensus on what these kind of measures should be. Each of them has their different measures of validating or verifying things. So as I was saying, because this data model is very flexible, there are pros and cons to it. At the end of the day, anybody can add any tag to any element. So I can add name is equal to something. I can add nm is equal to something. I can put naam is equal to something, or I can put any rubbish in it. Nobody or the technology doesn't stop me. There's no constraints to what I can put in. Another sort of challenge is when people who work with this data, they often have complaints that, okay, I want buildings. Why do I have to read the nodes? This is a very simple example, but when you're dealing with large objects like roads or other kinds of things, there's no nice categorization. What I mean by that is, suppose I want to find all hotels. So I need to go and find how people generally tag it and then query for that. We'll come to that a little bit later. There are all of these other complexities of the data models which you need to understand when you're working with that data. There are, of course, softwares which make it easy for us, but these are the challenges which are there. And one more sort of thing is that the same element can represent multiple things. So a typical example would be that all the nodes of a road, one of them could be marked as a traffic signal as well, right? Another one could be the end of a footpath crossing. So the same thing can represent multiple things in the data model. At the end of the day, how people generally build a consensus is there's a wiki. Yeah.
To a very basic question, as you said, there is imprecision in GPS.
Yes.
So could it be that, he's walking around, he's filing some information, I'm walking around, I'm filing some information, but the notes never quite align because there's a couple of meters of difference between his and mine.
Yes.
And the system just gets inundated with many different notes. We're not consolidating our knowledge around what to. Is that a way to think about it?
So that is quite possible. But generally what happens is so we'll come to that editing process. So generally, if I walk around with the GPS, I don't just put my GPS data in it directly. There's a process where I put it on top of satellite maps and then draw it. Because what will happen is two people walking or even me following on the GPS on the same road, they will never match exactly. So there's a whole process called map matching where you try to map a GPS trace to a road or a location. But how OSM generally works is that I can upload my trace to OSM if I want to, and then draw on the basis of that. So that sort of is how this problem is, solved. Because GPS,
Human being that's going to draw.
exactly.
Using all the traces.
Exactly. So automated edits are generally frowned upon in OSM. So at the end of the day, this is just one specific source which I want to highlight. There's a wiki on OSM which generally has all the tags and how that information is to be used. So are you querying for a pharmacy or are you querying for a ice cream shop? So each of them has specific tags which you have to enter while entering that data, and you have to query based on those tags to get that information out. So this is something that we need to be aware of. You remember I had spoken about all of those features earlier. The question which I talk or which I'm most often asked when I show OSM to people is that this doesn't have all those features. Why should I use OSM? I have this Google Maps on my phone which gives me all these features. OSM doesn't give me that, which is a valid question. But it fails to understand that OSM is not a mapping application. At its core, it is an open database. It's a platform where anybody can enter data and anybody can extract data from it. The website which you see is just one representation of that data. And why this is very important to understand in today's world is we are moving away from those static maps. We are going from, reports and maps to actual data. So like if you go to government and they give you a PDF of a scanned copy of a table, you don't want it. You want the CSV file, right? Similarly, if you're working with mapping data, I don't want that static map. I want the actual lat long. I actually want the lines and points and polygons. And OSM is the only sort of platform or source of this kind of data which is publicly available. Again, I want to reiterate, OSM is not a map. It's not an application that I can install on my phone and use day in and day out. It's not a routing engine. And why this is important is the whole philosophy of OSM is that I give you the data, you build things on top of it. So there is a large, healthy ecosystem of ways in which you can build your maps on top of OSM. So like I want an interactive map to be made out of the OSM data. I want visually nice looking maps out of it. So you will have to create what are called tiles. So there are different projects for making tiles. Okay, so think of it this way. When on my dynamic map, I will zoom in and out, right? So technically, I cannot expect that the server to create those images for me on the fly. So how they go about it is that they create these cached squares of a certain polygon squares across the globe, and I can just download those squares to my phone, or my phone does it automatically. So those are called tiles. So it's called tiling, where all of these things are created for you in advance. Then routing is
Yes, sir.
Yeah.
What is tiling? What is plain tiling?
So these are two projects which are useful for creating those tiles and visual maps.
Or create.
Yeah,
Alternate.
yeah, exactly. Tile. There are library. Exactly. It's not necessarily a pixel because a pixel. So yeah, you can think of it like a pixel, but like what happens is tiles can be more complicated. I can have different layers. I can have all the roads, all the buildings, all the points of interest, and as different. Think of it like layers of a cake. I have multiple layers which all fall on top of each other in 2D space, but they're visually different, right? So I can filter them. I can say I only want to show major roads. I don't want to show minor roads. So you can do all of that. It need not be a static image. While many tiles started as static images, but now they have moved on to something called vector tiles, which is this dynamic part of actually being able to query and get the lat long information out. Yeah. So tiling and mapping is a whole different, like I can talk about it for another 15, 20 minutes, but it's something which you need to do if you're building your own maps. Similarly, if I want to do routing, OSM gives me the data, and there are different routing engines which are openly available as open source projects. So 3 examples are OSRM, Grasshopper, Valhalla, which I can use to get directions, routes, drive times, map matching, traveling salesman problem, all of this on. Well, some of them allow you to add your own traffic data. Why that is important is I was previously working for an organization called Ola, where we build their Ola maps. Now, Ola has something like 2 million cabs on the roads. So they have good telemetry data of the congestion on the road. So I can calculate the congestion and add it to this and get accurate drive times.
But imagine and try point A to point B in India.
Yes.
Case 1, there is an upgradation of the road quality. But these algorithms will treat all roads as roads.
No.
So they
take
of the road characteristics.
They can read all of those parameters which are present in OSM. So I can add like whether it's a motorway. So the basic thing is what type of road it is. Then I can, yes, the surface is the surface of the road, the speed quality. Yes.
So when the routing engine makes a prediction,
exactly.
it's sensitive to road characteristics, but not to traffic characteristics.
Exactly. Yes. Again, the point of this slide is to indicate that all of these projects are there to deal with this data if you want to run some analysis on top of it. Like for one of my previous projects, we worked on figuring out to assign this was a banking company, to assign the users to their nearest branch sales agent. So we had to do something like 1,000 branches to 5 million customers. So those amount of calculations you can't really do using Google Maps. You would have become bankrupt. So you will have to use something like this to do those calculations. They'll be accurate, but they'll be relatively, they'll be approximate, but they'll be relatively correct.
Or they become a first cut and then you the cut.
Yes, exactly. Depends on your load. So if you're doing a few hundred, it's free. But the moment but then it scales up very quickly. So to give you an example, somebody like a mid-level company, their bill suddenly went from a few $100s to thousands of dollars, I think, when they last increased their prices.
I think Oza CEO said that they spend 100 crore a month or something on
because I used to work in Ola, I can't talk about the numbers, but they are sort of accurate. So again, the philosophy of OSM is that it tags what is there on the ground. So it also tags that this is the boundary claimed by India and this is the boundary claimed by Pakistan. But it also marks what is the de jure boundary, what is there on the ground. So you have all of those boundaries in the database. It's up to you which one you want to use.
So I had a question based on that. For example, in civil wars, the borderlines are dynamic. Is that something that that OSM can help, say in Ocean person with, like say in Khartoum and Sudan,
right,
the two belligerents kept fighting?
So at the end of the day, yes, people do update these things, but I'll give you an example. The Ukrainian chapter of OSM requested the community not to edit OSM after 2022 because they didn't want to give new data to Russia, right? So while it's possible, there are also these like, please don't edit, and people follow that. At the end of the day, if you want the exact Sudan border, maybe people will put it in, but you have to depend on them putting it in. And the third part which I talked about was doing the location search, going from a location to a lat long. There are again so many different projects which are there for that. You can do various things One is called geocoding, where I have a complete address and I want to go from that address to a lat long. Then there's a reverse part where if I put a pin, I want to know the address of this. These are two features all of us use in Zomato, Swiggy. When you put a marker, automatically that address comes in. Or you type your building name, you expect that marker should come at the right place, right? So these are called geocoding and reverse geocoding. Then there's something called autocomplete, where I will just start putting in a few alphabets, and the whole name should come in with the lat long. Then there is something called structured geocoding, where I put in an address and I want it to be broken down into its components. Okay, this is the city, this is the neighborhood, this is the pin code, this is the road, and so on. And there's also something like place details, that I click somewhere. Okay, this is a shop. What are its hours? What are its name? What kind of things does it sell? Right? As long as those pieces of information are there in OSM, you can extract it using these kind of projects. So to get started with using OSM, it's very simple. You just need to go to the OSM website. You need to click on sign up, enter your details. Their email will come. You just have to say that it's your email address, and then you can start editing. Right? This is practically very easy to do, but you need to know a little bit of how to edit, how to do those things. So that is something which anybody can learn in a few minutes. Actually, I have done these mapping exercises in schools and colleges, where it takes 10-15 minutes to get people started on their areas. The sort of challenging part, which is related to your point, is that I have some data. How do I get it into OSM? So there are different ways of getting data into OSM.
Tried several times to use OS.
Okay. Yeah. So again, these tools have different learning curves. So this is one tool which I use very often, called Vespucci, for adding points of interest for shops, etc. Again, there is a learning curve to this. What I generally suggest most people to do, again, in OSM, there are two things. One is called armchair mapping, where I sit at my home and map something which I know by looking at a base map. The other is actually on the ground. So if you want to map on the ground, you can use a mobile tool like Vespucci or OSMand or anything else. Otherwise, what mostly we get started with is the web based of armchair mapping, that I open up OSM, I log in, and then I can start editing, and I see a screen like this, where I can draw on top of the satellite base map. This is what I would say 80-90% of the edits to OSM in India are made this way. Very few people actually go on the ground and do edit. For advanced editors who need advanced functionality, there is a tool called JOSM, which is also there. It's just for this thing. But one important thing to sort of remember is that there's a whole ecosystem of tools and techniques around OSM for different purposes. So Meta and Microsoft, using AI, they had extracted buildings and roads based on satellite data. Again, they are giving this free to OSM users, that please use this to add these roads and buildings to OSM. So there are tools like Rapid Editor, which helps people who don't know what to map, but they just want to contribute to OSM. They can use this, and they can verify that the AI detected roads and buildings, are they correct or not, by looking at the satellite data, and just by one click add it to OSM. Then coming to that point which many of you had raised about the quality checks. How do you know whether this data is correct or not, what somebody has edited? So there are multiple tools. These are just two examples which I've given. On the top is Osmo, which is a French tool, which sort of highlights which are problematic edits in a given area. It can programmatically detect certain things, that maybe the road has too many curves, too many edges, or maybe wrong things are tagged together, things like that. There are some 150 different rules which are applied and can highlight things. And people usually use this for editing and correcting data sets when they want to. Then there's something called OSM char, which is useful for just figuring out what are the edits happening in a given area. It will tell you that the yellow one is a new road, and the blue one, so yellow one is a modified road, and the blue one is a new road which has been added. So something like this, an experienced person can look at and verify whether that's correct or not. There's again no way that somebody has to actually verify. If I don't like it or I think it's incorrect, I have to go and modify it. But till then, by that time, it becomes live. So very often it happens that a lot of wrong data goes into OSM and then it takes some time for that data to get corrected. But it's not that, okay, I have to send data and somebody has to verify and only then it will go into OSM. These are just two examples. Larger organizations have more advanced processing scripts to verify and highlight certain things. So think like when we were at Ola, we had scripts to identify things which may be potentially wrong and that we won't add to our data set. Or places have, okay, is my road or sorry, where should I map is a concept which large organizations would have, like including Ola, which happens at Mapbox, that I have maps of India, okay, but maybe Mumbai is very well mapped and some tier 3 cities not well mapped. How do I identify that? So because the data is freely available, you can build tools and scripts which run on that data to highlight these certain things. So this is one way in which the data quality is assured to a certain level. There are other mobile clients which can be used for specific purposes. So, for example, every door is something which people use specifically in Europe for adding address information. That's not so relevant in India because our addresses are not very accurate. Then maps.me is there, organic maps is there, Go Maps is there. There are multiple mobile clients which can be used for different purposes with OSM data set. One important point to remember is that OSM has become so useful for many organizations. There are large-scale contributions happening. What I mean by that is, for example, the government of India realized that there's a lot of data which they have, which they want to give out in the public. So earlier they had this portal called data.gov where they should just put in data, but hardly anybody used it. So a few years back, the Pradhan Mantri Gram Sadak Yojana project, they released a lot of their data and they wanted that data to come in OSM. So they did a MOU with different organizations to help them do it. So for example, this is the amount of rural facilities that they have open sourced, the map on the left. And people are slowly adding that one after the other by manually verifying it. So roads are also there. They're just not on this map, but that also people are.
Roads are all coming.
They're all. They're all coming in. People are using that to verify. And again, as somebody who uses that, I don't trust that data 100% because there's a lot of wrong data there as well. It's a mix of.
Who doesn't know their AMGS sign?
Or see, at the end of the day, what happens is it's a mix of proposed roads and current roads. So I have to actually, you will find roads which are going through, say, fields. And when I look at the satellite map, there's no road there. So it might be a proposed road, or it might be a road which once existed, now farming happens on top of it. So it's a good source for places which I don't know, but I can start mapping there using this as one of my sources and satellite as more of the true nature of what is happening. And transport admin, government facilities, rural facilities. And similarly, they had released the health facilities data like rural clinics, etc. I think in 2020. And then during the COVID pandemic, one organization had a lot of free time. So they said, we'll import all of this into OSM. So you can see on the left, the data of rural health facilities in OSM in 2019, and right, you can see after the import in 2021.
It's wonderful.
This is an organization called RMSI. So that's an GIS organization based out of Delhi. So they are doing a lot of things on OSM. So there is a whole process which they use. So they put that in the software. They looked at verifying it by looking at satellite imagery and other sources, and only accepted the ones which they felt were actually there on the ground.
That for the four things that are there on the rural facilities.
Right. So that's why the community is very important. It's not a direct import. Somebody looks at each and every one of those records before ingesting it.
United States Tiger database
Yes.
was the beginning of OSM.
Yes.
It's all perfect data. We just here. It's an endless struggle.
Exactly.
That government is saying something, and then you wonder, does the road actually exist?
Right. But at least what happens is now people who are doing armchair mapping have a different source to look at, and they can add that information by checking it. So that's actually part of the flowchart which they'd use. I can share the entire, it's a wiki page on the OSM wiki. They've given the entire details. So basically what they did was they broke the data by districts of the country, and there was a different set of 4 people working one by one for each district. They looked at each of the records by placing on satellite map. They used to approach it and check whether there's something on the ground there. Because very often you can sort of make out, okay, there is a building here. Is there an open space outside it? Or what exactly is nearby, and based on certain parameters they would verify. There were certain cases where the location was shifted by a few hundred meters, like GPS issues and all of those. Then they had to correct them. So there's a whole write-up. I can share it with you if you want to. Then one important thing which has happened in 2022 is that Google has become the big leader in mapping. So all of the other organizations had to decide what to do. How do they get and improve their maps? So large companies such as AWS, Meta, Microsoft. Now these are the 3 biggest technology companies in the world. They came together along with TomTom. Many of you may not know TomTom, but that is a large mapping provider in Europe. So a company like TomTom deciding that their own data is very difficult to maintain and they cannot update it, but they can utilize the OSM community and create maps together. So all of them came together. They said, we'll give you our data. We'll add our own technological expertise, use OSM data, build something together and release it. So this is a project called Overture Maps, which they then open source and gave it to the Linux Foundation. So this is something which is sort of the newest thing in the mapping world connected to OSM, where companies are coming together and deciding that working in a proprietary manner is no longer profitable for us. We need to work in the open. We need to work along with the community. We need to utilize their expertise, and only then we will succeed. So this is something worth reading and looking at. Yeah.
Curious, are these companies operating in India in a way that is meaningfully improving the India?
Definitely, Meta was doing it for a long time. In fact, if you look at any of their maps, be it on Facebook or Instagram, you will see that they're using Overture Maps. So, for example, every store that is there in Facebook, that actually has a location associated with it. So that comes in this data set for anybody to use. So we'll come to the most important part of how you can use OSM data. So far was how you can add to OSM data, but biggest strength of OSM is that you can get that data and use it as for whatever purpose you want to. So the simplest way of using is there are country level and region level extracts which you can use. So I can just download all the data that OSM has for India. It would be, I think, around 1 to 1.8 GB in size. And that's the whole XML PDF format, which I can process and read as I want to. There are these standard GIS formats called shapefiles, which you can utilize and download in that way. So, yeah.
So, is it true that border software foundations for geospatial work are trying to move away from shapefiles as like a bad engineering architecture?
Yeah, shapefiles depend on something called the DBF format, which was made in 94. So it has certain limitations, like I can't have a column name more than 10 characters long, or I don't have that many options for storing numbers. So there are certain limitations to the format, and that is why now you have better formats to use the data, but it is a de facto format which almost anybody can use. So it's still there, but you can convert it to any other format that you want to use. If you don't want to work at a country level and you want to work only at a local level, so then there are ways of extracting data for certain regions. So this is a site which I use often called BB Bike, which you can download data in different formats.
Do is I would take like 1 kilometer by 1 kilometer of my housing.
Right. Correct. You can do that. You can do that. Yes, you can do that. Then if you want the entire database of the globe, there are something called the planet files, which I think some 192 GB now. So you can download the entire globe data set and process it in whatever tool that you want to.
So isn't it embarrassing that 6% of the world's population is generating a trivial 1.8 gigabyte file.
So what happens is, if you look at some data, like you look at, say, the German OSM community and the French OSM, there's a huge difference. Like the German is something like 6 GB, France approximately equal size is something 2.5 GB. So yes, community activity. Because as it happens in India, there are a lot more people just taking data and very few people adding. Like in India, there is like 250 users per day is the maximum, 250 to 70. Normally it's around 200 to 20 users per day. Contributors.
Which is abyss.
Which is, yes. Then if you want to just extract certain specific types of data sets, there's this website called Overpass Turbo. The language to use that is a little bit complicated, but there are the ways in which you can extract this. So I just ran a query for giving me all police stations in Mumbai. So I just had to query for where amenity is equal to police. And it gave me these data sets of 80 nodes, right? So if you want to just quickly extract certain different, say, points of interest or roads or something specific, this is a very easy way to do that. If you have more technical expertise, then you remember I had spoken about the Overture maps. So this is their Overture Maps Explorer. And this is our Chakala area where you can see all the data which they have for this area. So you can see that this has more points of interest than what was available in the OSM database, because what the Overture Foundation has done is taken the OSM data, added the data from Microsoft and Meta and other places, verified it, standardized it, and are releasing it in a standard format. This is also, yes, it's open source and the data is openly available, yes. So these are some of the ways in which you can do it. Any questions so far?